Good morning, everyone. I'm Professor Nguyen, and welcome to chemistry. The goal today is to balance chemical equations, converting gram to moles, and those are the two important items for us to do stoichiometry or chemical calculations. All right, so let's get right into it. To balance chemical equation is to make sure the quantity of um, each for each element is the same for both sides of the chemical equations. The left side contain reactant and the right side contain products. All right. So you start out with the unbalanced equations, and then you balance off the atom of one element at a time, and then sometime you have to go back and check and rebalance, and then you verify everything. Okay, but before we get into that, I want to go over this um, study guide real quick. This outline the important concept. Okay, the type of reaction first, which is the classifying um, what type of reactions. There are four fundamental types. The first one is a combination. If you have two or more reactants combined together, like a carbon and oxygens combined together to get one compound, for example, CO2, carbon plus oxygen gives you CO2, that means you have a combination reactions. So pretty much it tell you the equations is self-explanatory. Okay, tell you what it is. Decomposition reaction is the opposite when you have a compound with two or more elements breaking down into two or more compounds. Okay, single displacements, look for single elements. If you have one single element, then you know you have a single displacement because A will displace C or B. Okay. Now, double displacement is when you have a two element compound, two or more, plus another two or more elements compound, and then they swap. Okay, A go with D, and then C go with B, or B go with C. Now, usually, whichever element that goes first, they want to stay first, which is the cation. Okay, the positive ion. The negative ion always goes second, always. Okay, that's the hint. Now, for double displacement reaction, you're gonna run into special products like a gas. We call that gas evolution reactions, like a liquid, like water, or a solid, and that's precipitate. Okay, and in this case, we have a name for it. If the reaction form a solid product, we call that precipitation reactions. If reaction form water, um, most likely it's going to be a neutralization reactions. And if the product is a gas, we call this a gas evolution reactions. Okay, we're gonna run into a few of them. Like this one right here, you have sodium carbonate react with barium chloride, sodium swap and take the chloride, and barium paired up with carbonate. Now we still have to do the adjustments, like you have two sodium here and two chloride here, but you don't have to write Na2Cl2. Uh, you can just write NaCl because Na is positive 1 and Cl is minus 1, so they go perfectly together. Similarly, barium is plus 2 and carbonate is minus 2. They go perfectly together. Now, how do you know the charge of the ion? Remember on the very first module, I have two handouts. One is the periodic table, and the second one is the naming ions. In there, you will find the charges of all ions that you need. Okay. Now, this type of reaction is a double displacement. However, the product is a solid, so we need to classify a little bit further, more specific, which is a precipitation reaction for this one. Okay. Now, this one is a typo. PbSO4 should be a solid. So do me a favor, fix that. And this is also a precipitation reactions. Okay. Now, look at the third one. You have aluminum is a single element. Therefore, and you have this compound has two parts, the copper and the sulfate. And obviously the aluminum displays the copper. So we call this a single displacement because aluminum is a single element. All right, moving on to solubility rules. Now notice that we identify barium carbonate as a solid. And how do we know that? Okay, well, we have a set of rules that help us to identify the solid. Solid compound means precipitate or insoluble. Okay, here's the hint right here. If a compound or molecule is soluble in water, you label it as aqueous, meaning water. Otherwise, label it as solid if it's insoluble, or precipitate. Liquid if it's obviously a liquid like water, or a gas, obviously a gas like CO2, nitrogens, oxygen. Okay. Now, okay. So with that, I would like you to go through the list and and identify. Okay. Uh, like for example, the first one, sodium chloride, it's soluble, and we know that sodium chloride is salt, very soluble in water. Okay. So on and so forth. Um, like sulfate, anything with sulfate, you guys see right here. All sulfate are soluble except with mercury, lead, there you go, strontium, calcium, or barium. Okay, so if you have barium sulfate, calcium sulfate, strontium sulfate, lead sulfate, or mercury sulfate, those are not soluble. Those are solid. All right. Here's another example uh, with double displacements. And the product is barium sulfate. That's the insoluble one. That's not soluble. Okay. And if you read number 4, that will tell you right there. They are soluble except, with the calcium or barium. So that's not soluble. We label that as solid. S is actually for solid. Everything else soluble. Okay. Now in this one, I want to show you further. Okay. There's 4 fundamental type of reactions, and now this is the type of equations. Even you already know what the reaction is, thinking that we can only write one equation. No, we can actually write more than that. The first equation we write is called molecular equations. It shows all the molecules. It shows all the physical state, aqueous, soluble in water, or insoluble, solid. Okay. There are also 2 other equations known as ionic equations. When you break all the compounds into ions, except the solid one, because they're solid, you get all the ions, and then you cancel out. Now, see the note right here? Only break aqueous compound into ion, not solid, liquid, or gas. Okay. Now you got 2 potassium plus on the left and 2 on the right. You cancel out, just like a mathematical equations. Nitrate is also the second one that you can cancel out. Therefore, you left with barium 2 plus and sulfate 2 minus. give you barium sulfate. Now you always put the positive one first, okay? Acid-base reactions um, happens when you have an acid, like nitric acid, react with a base, like calcium hydroxide, and that will form what we call an ionic salt, like calcium nitrate plus water. Water is always a product for any acid-base reactions or neutralization reactions. Reduction oxidation reactions is when uh, oxidation numbers changes. Okay, you can think about oxidation numbers like a charge, and the thing about oxidation number is assume all atoms each has a charge. Okay, this one is obvious. Magnesium by itself is neutral, which is 0. Oxygen by itself is also 0. But when making a compound with oxygens, magnesium is +2, we write 2 plus, um, and oxygen is -2. Okay, so magnesium go from 0 to +2, we call that oxidations or oxidize. Oxygen start out with 0, become -2, and we call that reduction or reduce. Okay. All right, so that's good enough for reaction type. Now we're gonna get into the calculations, and these are the example that I would like you to try first before we get into the answer. Okay, so keep that in mind. We should have um, the answer for that one. All right, but remember, um, converting gram to mole and mole to gram is really important. And okay, I am going back to our class, and right here, chemical calculations. Okay, I want to show you the first thing we got to do is to balance equations for that problem that we were talking about. The ammonia react with oxygens to give us NO plus water. Okay, here it is. Um, okay, here it is. We got ammonia react with oxygens to give us 4 NO plus 6 water. Well, the reason that we come up with 4 um, is because the hydrogens, we can make it 6 or 12, but 6 did not work out well, so that's why we decided to make 12 hydrogens. The only way to make 12 is times 6, times 4, 4 times 3 is 12, and that's lead to the 4 for NO as well for nitrogens. Now, the good thing is it adds up pretty well for oxygens. You got 4 oxygen here and 6 oxygen. That make it 10 oxygens. Okay. Now, remember, after you get the balance equations, if you are given mole, you can start with mole of ammonia, and we have to calculate the moles of NO. If you start out with mole, that's easy. You save yourself one step. The ratio of 4 moles of NO, the equation tells us that every 4 moles of ammonia, you get 4 moles of NO products. All right, so you make sure you have to be able to cancel out what's given to get what you want. So 4 moles of NO over 4 moles of ammonia, and then you cancel the mole, just the unit ammonia. So you take 15 times 4 divided by 4, obviously you get the same numbers, but that's the products. If you have 12 moles of oxygens, well, the ratio is going to be different because you got every 4 moles of NO form, we need 5 moles of oxygens. So 12 times 4 divided by 5 should give us 9.6. Finally, if we got 2.5 grams of ammonia, we can figure out NO by 1 mole. First, we have to convert ammonia to mole. 1 mole is 17 grams. 0.04 because ammonia is nitrogen 14.01 plus 3 hydrogens 1.01. So you got 17.04. That's converting gram to mole, and then you have the ratio of 4 moles of NO every 4 moles of ammonia. You cancel out, and then you're converting NO to gram. Molar mass of NO is 30.01 gram per mole. You cancel out a mole. You take 2.5 divided by 17.04, and 4 is the same, times 30.101. You should get about 4.40 gram. Okay, that is stoichiometry. All right, now we have more of the foundations exercises like mole to mass conversions. You see this in the study guide, and here's all the answer. Converting gram, mole to gram, you multiply by molar mass. 18.02 is molar mass of water. Now, if you go from mole to gram again, molar mass is 44.01 for CO2. You multiply again, you get the gram. If you go from gram to mole, these are examples in the study guide as well. At the beginning, you divide gram divided by molar mass. Or you can set up this way, 1 mole equal to 12.01 gram. So you should get 0.17 because 2.0 is two significant figures. 125 gram of water to mole. Now this one, you also divide, but you want to cancel out gram. 1 mole of water equal to 18.02 gram. And you should get about 6.94 moles. Okay, here's a more example about chemical calculations. In here, let's say we start out with 2 moles of CH4 and we wonder how many moles of water are formed. So take a look at all of them. You will see the ratio, and remember the ratio, the mole ratio is obtained from the balance equations. So again, balance equation is really important, and we have to start out with mole. If you have if you're given gram to start out with, you want to convert to mole first before you set up that ratio. Okay, and then when you get the moles of the product, you can convert that to gram by multiplying with the molar mass. Okay, please go through all that and check the answer, and let me know if you have any questions. Thank you all for watching.